How's it going? My name's Daniel Reynolds. I'm a public school teacher at Buffalo Public Schools. I was talking about Computation Jockey today, and that's using control surfaces like turntables and MIDI controls in order to let youth control scientific and mathematical visualizations, and they think it could help in education. So thank you very much.
So this is Computation Jockey for education, outreach, and expression. And it's going to be by me, Daniel Reynolds, from Buffalo Public Schools. I got a degree in teaching. Actually, I teach English as a second language, and I'm in the math classroom, and I got a lot of STEM initiatives. And someone, Christopher Nicolai, he had helped me with some of the technical demo. So what is Computation Jockey? Basically, it is the idea that you could, DJs, they're very quick at going from one song. If you stop the record, they don't like that, you know what I mean? Because you have to keep it going at the party. And sometimes when you're doing a presentation or something, you got to stop and, fix something. I want you to be able to compute. Sometimes they say driving computation like a caddy. If you know what that means, like a Cadillac, you're just going through, you can control anything in real time, no problems. We were doing the theoretical underpinnings. When I was a kid, I just remembered this quote. It said, "Whatsoever I play, it's got to be funky," by James Brown. But when I looked it up, it turns out there's no results for whatsoever funky. It turns out they say he was saying, "Whatsoever I play, it's got to be funky." But I had already started, because I usually use whatsoever and funky in a couple sentences a day. So it's kind of funny that there's none on Google. But this was me. First, I was worried. I said, if it's not whatsoever, I still, my theoretical, we just had, these univalent foundations of mathematics. Are my foundations wrong, for funkiness and Wolfram and all that? But my friend Christopher helped me. For the top proof was my original for whatsoever, but he helped me sync it up with whatever I play. So even if whatsoever isn't a word, I think our theoretical underpinnings are still sound. So now I looked up Wolfram funky, and only a couple of these are from Wolfram. Like they said, they found a funky formula, funky integral. Some up there, Wolfram alpha, you see, is the fourth one down. Another impressive release. So we got some Wolfram. I even got to find Wolfram Brunke, stop your fever. And Wolfram Brunke is pretty cool. Now he's really influenced me. So that's kind of the kismet of looking up things on YouTube, on Google is. But we want 100% of these top 100 searches, to be Wolfram. So what my friend Christopher helped me do is we make the Wolfram Funkometer, and it's scraping the top 100 searches to see how many are related to Wolfram, the company. So as the top 100 searches go up, the Wolfram Funkometer is going to update in real time. So that's our goal for the year, is to try and get it to like about 90% of the Wolfram funky searches are really about Stephen Wolfram and his company and all that. So I did a lot of hip-hop education. If you go to this notebook and get the links, you'll see some hip-hop, UB hip-hop, that's University of Buffalo hip-hop. I was trying to teach kids to make positive social change music about stopping violence and cleaning up recreational spaces and stuff like that. And people were always saying, you can't teach STEM. Like, it's good you're teaching them about being socially conscious, about cleaning recreational spaces, but how are you going to teach them science? They can't pass the exams. But I was seeing a guy, Jizza, from the Wu-Tang Clan, was speaking at MIT and Harvard. I spelled talking wrong, but I was typing this morning about STEM education. You can go there. A guy, Christopher Emden, who was working with Obama even before, was a guest speaker at our school, talking about hip-hop and all that. So we need to make computation funky to reach the kids. Well, let's look at the word psychedelic for a minute, and nothing about like any substances or anything. It's about making one's mind visible, like your psyche. And that's why I want to help the kids be able to portray their minds on the screen in real time. And two, projecting one's soul. Psyche can mean mind or soul. There's a few different ways to translate the roots and everything. Here's a quote from Namjoon Paik. He's called the founder of video art. He was doing CRT art and everything back in the 60s. Said, "We are not yet aware that telepathy is conveyed through the resonance factors of the mind, and the electromagnetic vibration of the head might lead to electronic zen." You can read that in a book on video art by Judd Yalkut, who died recently. and is called it's a psychedelic lineage of Wolfram. All of these are really mind-expanding, colorful graphics from this mathematical graphics by Tom Wickham Jones. When I saw that cover and inside, back in the day, I was like, wow, I want to, make this real-time crazy stuff. Graphica 2, different artists, Michael Trott, and we also had, the mathematical journals and all that. Here's Einstein a Go-Go here with his looking cool. The first Wolfram webpage looks also looks pretty trippy looking. Here's some literature that was influencing me. The first book was influencing me was Mathematical Basis of the Arts by Joseph Schillinger. I had read that book, and then Marshall McLuhan, Understanding Media. Expanded Cinema by Gene Youngblood is a classic of video art with Buckminster Fuller doing the intro. And Hyperanimation was a book on, museum quality art of this kind. Here's two good books recently: Chromatic Algorithms, all about video art and chromaticity. Also, The Emergence of Video Processing Tools is a 2-volume set. And I actually got a quote from that one. It says, "The history of conceptual filmmaking," I spelled computer wrong, and motion graphics are inextricably connected. It kind of ties in video art and the computer art of the days, back in the 60s and all that, 70s. Here's some pioneering video art examples. Bill Etra was a video artist, and he was using biofeedback to animate a heart all the way back in the 70s. And now I know Steven collects a lot of biofeedback data and all that, and we can try and do it now a couple decades later. Namjoon Paik, he had the first worldwide satellite art that was coming from France and the US and all around the world. It was beaming back in the 80s, and I'd like to do, some real telemetric art. Actually, IMAX even contacted me yesterday. I hope in the future we could partner with some GPU partners and do high-end visualization contests where youth could be into real, the full IMAX quality and stereoscopy and be competing, doing shows of STEM outreach with Computation Jockey. And this was a friend of mine, Ryan, who was the first kid in our school to get into the University of Buffalo gifted math program. But unfortunately, he used to always take different substances and stuff. He was one of my best friends, and he actually passed away. And he used to try and expand his mind by taking things. And I think maybe this could be a way that kids wouldn't turn to drugs. They could try to, expand their mind through using control boards. So I think it would even maybe save some lives or something, help kids some of that common confusion of youth and all that. Development milestones. We got positive stories of STEM. I spoke at a new school in New York City on this idea, outlining it. And then last year, I spoke at a technology conference, and I want to thank Chris Roney for the Mathematica Symposium there last year at New School. Here's Stephen, mixing with some triangulations in the back. Ithaca College, I spoke for 1 hour, is one of their main speakers at their Ed Tech Day at the Wolfram Summer School, where I was getting the different MIDI devices going in. I did a little residency in Somerville outside Boston for 3 weeks after summer school, developing the topics more. And then at Buffalo Infringement Festival, I was at a local mall there, the Main Place Mall. I was doing CJ, using some Wolfram CAs and stuff, and trying to use it in the classroom as well. See how we all are on time. Okay. So next slide. Telematic, and actually I'm going to use a whole bunch of quotes from Parliament, Funkadelic, because I have actually 6 quotes. I don't know if I missed any, but who's ever heard of Parliament and Funkadelic before here? Yeah, I've got a couple of quotes. The first one, because you'd be surprised how much science and stuff and tech is in some of their lyrics. So there's "Untied dog in a telematic society ain't your average huckleberry hound" from George Clinton's Atomic Dog. And it's basically telematics through the telephone lines and all this. And we still have, our basic instincts. That's what, the dog and all that inside you is. But the telematic future of the world, how do we take our primitive nature and bring it into the modern society? Stephen was saying at the summer school that Roger Penrose writes real good Mathematica code. But like here's some clips of his talks, and he's always using overhead projectors and stuff. So one of my goals is to get Roger Penrose to sort of CJ some of his talks coming up. So that's one of my goals for the year. Here I got a quote. Who's ever heard of Zhang Tong? He worked on boundedness of primes. Well, anyway, he's here interview with David Eisenbud from Mathematical Science Research Institute, and David was asking him, we're talking before about how you think about numbers, and I thought it was interesting. So how do you see numbers? And Zhang Tong says, I see the numbers in my mind, or I say in my brain, but how's the situation, the position of the numbers is very hard to say. I got some very strange feeling like the numbers appearing in a line, maybe like the matrix, maybe like the cube, or something like this. I have such a feeling, it's hard to tell by words. So I think using stuff like this, people could express in their mind what they see when they have mathematical visualization. Sometimes you have higher dimensional understandings and all this, and this could be a way to express it. I got a song, another Parliament one. I count the moments we're apart and add them up mathematically. I multiply them by the kisses I've been missing supposedly. Divided by the attention, not to mention the affection. Subtract that from your growth potential and see I ain't missing none. Because any percentage of you is as good as a whole pie, and any fraction thereof returns dividends of interest. Yes, any percentage of you is as good as the whole pie, and any fraction thereof returns dividends of love. And I really love math, and that's basically why I'm here, and I want to share that with the kids. I'm going to be showing some real-time fractal generation coming up. This is the Mathematica code. We're using OpenGL. My friend Christopher Nikolai helped me, and we're taking a generalized form of the Mandelbrot set. Has anyone ever heard of anything like zeta second plus c or anything like that? Currently, if you use Mandelbrot plot or Julia set plot, if you put in some of the non-integer exponents, it won't work. So this is what a workaround that we did so you can smoothly move the boundary even in the non-integer exponents. And I'm going to show that a little later in a tech demo. I just want to finish the talk, see how we are in time. Okay. Here's some more Parliament quotes. I said I had 6, so. Psycho, alpha, disco, beta, bio, aqua, do loop. And everyone's talking about do loops at Wolfram, all the time. So psycho, alpha, disco, beta, bio, human, U loop. What is the loop that, is our bio understanding? It's for aqua boogie. And, think a lot about water, how it affects. I'm interested in protein folding and maybe the effect that hydrophilic and all that has going on with it. So let's see. Here's Dr. Funkenstein. Who's ever heard of Dr. Funkenstein? When I heard this song when I was a kid, it really wanted me to study atoms and molecules, So when he says, when I start churning, burning, and turning, I'll make your atoms move so fast, expanding your molecules, causing a friction fire, burning you on your neutron, causing you to scream, hit me in the proton, baby. That was from Dr. Funkenstein from Parliament. Yeah, who's ever heard of Iggy Azalea? She's like a rapper. I think she's from Down Under and all that. First things first, I'm the realist. Drop this and let the whole world feel this. I'm still in the murder business, and I'll hold you down like I'm giving lessons in physics. So maybe Iggy Azalea could come up, show us, how gravity works with some CJ on one of her shows. And I was trying to compare it with Leonard Susskind here. Now, almost everything, if you change it very much, the charge of the electron, the mass of this or that particle, and the constants of nature, and how strong gravity, and if you change it by a few percent, 10%, some 20%, some 30%, you'd really be in trouble, and the universe would not look how it does. So I'm trying to create modules where the kids could actually turn the knobs and see, how changing these physical constants, a simulation of how the world might be different. And maybe I'll show that next year. I'm still working on it. How many slides we got? Okay, this is the last slide, basically. So the conclusion is, we now have the potential to build the ultimate art station that video and visioning artists have been looking for, and Wolfram language with CJ concepts have the potential to cap this off with STEM. And here's a quote I want to share from a guy, Bill Etra, who built one of the first video synthesizers. And he says, he's talking about the early days of TV Lab in New York and the Pike Ave synthesizer. This is what this image is. This is one of the first video synthesizers. And he says that this guy, Stan Brackridge, I came through the lab, and Namjoon was there showing off his synthesizer, and he'd taken color yolks, TV yolks, put it over smaller black and white yolks so they could distort the audio signals, and he had all these electronic oscillators and stuff, and it was total chaos. and the colorizer was from a Sony camera encoder, and they had 3 extra inputs, so the RGB also had cyan, magenta, and yellow inputs, and they could go through the oscillator and had various pictures in. And then he turns to Namjoon and says, "Can you make a tree?" And Namjoon, he was also a philosopher. People thought he was crazy, and he used to put subtitles on when he spoke English, but he had a degree, in philosophy from German University. He spoke 4 languages fluently, and he turns back and says, "Too young, still too young." The meaning is we could do all these oscillations and all these abstract patterns, as you can see on the image, but we couldn't do a tree at that point. And I think now, I saw yesterday in Charles Poo's talk, he was talking about geometry. He pulled up a mesh just by typing it in of Beethoven. So I think if you can load up a mesh of Beethoven, you could pull up a mesh of a tree. You know what I mean? Whether it's a fractal tree or any other type of tree. Probably most trees have some fractal aspects. So that's why I think we finally built it. And here's like a little picture of astral projections. This was something done in a planetarium at Rochester, Strasbourg Planetarium, by Bill Lettra way back in the day. And I like to do more events like this where people could like project their mind using these tools. I got some challenges because basically I think the only way to get people to like also do this would be to like challenge them. So if anybody can do any of these and really make it look good, I'm going to give you a $200 controller. So the first person to do any of these to my satisfaction will get a $200 MIDI controller called QNeo. And I'm also going to give you an official printed certificate from the CJ contribution to the community. And I'll also give you an abstract artwork that I drew. So if you do any of these, so you can make a song called Hip Hop Vibration. So you could do some sort of protein folding with MIDI controls, turn the knobs. You could have different states of folding based on the different models they got. You could scratch real LIGO data. You just scratch in, the neutron star collusion could come in and out as you're like scratching. You could find a funky curve from when I searched in Wolfram funky. One of those was about a funky curve. You could make a visualization. You could take the song Computer Love by Zapp and then have stuff. You could either emulate old computers or you could have something about old computer history. You could take Kraftwerk song Pocket Calculator and use the Inspire, and you could be controlling all the visuals with that. See if you can do that. You could map rotations in real time. So instead of looking at videos of polytopes being projected and like symmetries like Monster Group, you could turn the knobs and in real time, look for things in those polytopes and groups. And also any other legitimate advance, if you come up with your own idea based on what I said and you submit it to me, you can write to Wolfram Company and ask for me and say you're submitting, and I'll give you an artwork and a certificate. So basically I was going to do a demo. This turntable may or may not be working, but you see how I've got this up here on this. This is called a MIDI controller, and this is a XY grid. Is from something called a K-Oscillator Pro, and I also have another controller here on the floor. And when I step on the different controls or move them, they are sending to this computer right over here. And so I'm going to do a demo. Maybe while I'm setting up the demo, I don't know if anybody wants to ask questions because I think I got to move some things. I don't know if someone wants to pass this around or something. You can ask a question. Actually, there's only one mic, so you can shout out a question, and while I'm setting it up, basically you can shout out a question. Okay, if there's no questions, you can just like sit there and wait for me to get this going because we have 10 more minutes. Basically, this computer had been unplugged and it ran out of batteries, so that's why. So there's no questions. Nobody's got any questions at all. Nothing to ask. So lucky we got these couple of minutes to get this going. 5 minutes. Yeah. Basically, I've only shown it to a few classes. Like I was teaching a mathematical programming class at a school in my district, and I showed it to him. But it's really just getting started. So basically, I presented a lot, but having youth actually use it is just starting to come out. And I think that I want it to be for adults too. That's why I showed people like Roger Penrose and them. As I really think if you have a mathematical idea, you could show it using these devices, and they're really in real time. And once this demo starts up, it'll be going. Okay, one sec. So this website that I'm going to show you, the Fractal, is Mandelics, and I'll load it up here. So I type in this, I type in mandelics.com/photo. And this is OpenGL reading from, it's using the Wolfram web API to call for the complex expand that I showed you the code earlier. And it gives me a code blend. And on this computer, which had run out of batteries, I have to type blend. And all of my MIDI stuff and my turntable are going into here on the Linux system. And then when that goes, I can actually send it to the servers into here. With this thing having run out, we might not be able to do the demo, so I might have to do it downstairs and show you. Yeah. I got power, but this isn't my system, and if it hadn't run out, there's a couple different operating systems on here, and I keep trying to load the different ones. See how much time we got. Yeah, probably got to go down about 2 minutes, right?
You got a little bit longer.
Okay.
If you want to run right up until 11, that'll be okay.
Okay. I'm just texting this. Okay, my phone. Okay, I'm just texting this guy, asking which operating system. Okay, now it came up, luckily. I don't think I'll be able to show you the turntable because it's not reading it right now, but I'll show you the MIDI at least. Oh, actually, let's see if I put the needle on, hopefully. So like I said, all of these are going through, and I'm reading it here, and you're about to see this fractal change. I have to get the code again. And then once that changes, maybe I'll set up downstairs or something for the rest of the day. Does anyone remember the 5-letter word that I had said before? Okay, arose. So, anybody want to come up and they can be my volunteer, and that'll be the last thing. How about somebody just comes up, or I'm going to drag you out up here. Well, I'm not allowed to drag you because that's called assault, but I was hoping that would scare you into coming up. Just come up. You can. So I'm going to press this to show you what the other screen is doing. I was hoping to show you some video feedback art and stuff on the fractals, but with this technical, and I also have Christopher's waiting over in Buffalo. He was going to control some of the stuff live too, but with all these there's some video feedback. I'm not able to. So here's how I map it. So when I move this, you see, this is written in JS. And remember, the important thing for the Wolfram language is that the fractal that these values are going to affect, and I can load different fractals, are all without the complex expand, it wouldn't be possible. So basically, I just click on here and map it, and then I'll choose power. Let's see. Z power. Okay, so now it's mapped. And you see now when I switch to the other fractal, here we go. Okay, now look what happens. It's changing the power on my, they got this little screen here blocking it. But you see, it's actually changing the visualization. It's not, I'll switch to a different fractal now, and these are different fractals that we've saved on the presets. Would anybody like to come up and actually change the fractal with their, and you remember it's going to this Linux computer. Christopher, if you can hear me, the guy's waiting in Buffalo. If you can hear me, your password is Dizzy. Your password is Dizzy. If you see something moving on there, someone's changing it in Buffalo. So and that would so let's have one person, just one person come up and change the thing, like just one, you know what I mean? I shouldn't be the only one, but you can see that it's doing it, and it's doing it well. Here I'm pressing some stuff down here. Just move your hand around there, and that's just one variable. That's the exponent on the Z, but we can actually map like 20 or 30 different things. You can X offset, Y offset. You can make it more chunky. That's how many iterations and the graininess of it. We can actually we can take CAs, so he's got that going. And if we had, like I'm saying, people can change stuff from other places. So it's on rule 30, and when I click here, it should give me a rule 30 tiled.
Where's your music?
You want the music? Let's see. Okay. Well, since that's not exactly a Mandelbrot set, but let's do a song, me and him, called "It's a Mandelbrot's World." Let's change it to a bass. Here we go. Mandelbrot's world. Mandelbrot's world. Mandelbrot's world. Mandelbrot's world. Mandelbrot's I think we're probably out of time, but appreciate everyone for coming. Hope you can see the potential, and have a good night. And normally it's turntable, so thanks.